I'll be with your group till she gets here. Okay, Oz, can you sit closer to your group, please? Okay, I want you to start by just watching and not writing anything down. I think some of the beginning ones are self-explanatory. What I want you to learn from example number 1 is in this problem we have two separate sides, a left side and a right side. Okay, so left side, right side, and they are separated by an equal sign. Learning in this lesson, how do we attack a problem based on what we're given. So in this problem, do you see how the bottoms, the denominators are exactly the same? Make sure your earbuds are out. Make sure your cell phones are put away. Thank you. When the denominators are exactly the same, we get to wipe out the denominators, and all we have to do is solve the numerator. So in this problem, you are only watching. You're not writing this down. I'm just doing simple algebra. I'm going to choose to move the x's to the left-hand side. I have negative 4 equals. I combine over here to get 1x plus 1. Subtract 1, subtract 1. The only thing left on the left-hand side is a 1x. On the right-hand side is a negative 5. And now we have x equals negative 5. But at this point in your math career, you're going to learn a term that's called extraneous solutions. Turn back to your group and let's see what you remember from middle school. In middle school, you learn that any number can go on top, but we are restricted to what we can put in the bottom. What can you never have the bottom equal to? Turn to your group. Go. 3 seconds. Go. 1. To your group. 2. 3. The answer is 0. So if you don't know that, please write that down. You can never have the denominator equal to 0. So when I look at this original problem, I'm lucky because both denominators are exactly the same. You can do mental math. I have no problem with that. Or here, I'll show you how we end up getting this algebraically. I know x can never be negative 3. So when I get a final answer, I just need to make sure that x is not negative 3. Why is that? Remember, we got an answer of negative 5. But if x was negative 3, it is not. If x was negative 3 and I wanted to prove that this answer is correct, I would substitute in wherever I see an x in this equation. I do the math on the left, I do the math on the right, and then they should be equal to one another. Remember, for this problem, when you substitute a negative 3 and positive 3 would join to give you 0, and we'd have 0 on the bottom. It can't happen. We'd be breaking a math rule. Thanks, Jose. So number 1, the lesson for this problem is when you have denominators that are exactly the same, we can wipe out the bottom and just solve the top. The second lesson is we always have to make sure that whatever our final answer is, when we plug it in, we don't end up with 0 in the denominator. If that happens, we write no real solutions. Let's look at example number 2. I don't want you to write it down. I'll have you write it down when they start to become more difficult. Are the denominators the same? Yes or no? No, but they're really close. I expect your math to be able to recognize this. What can I factor out of both of these? Now, there's more than one way to attack this problem. There's more than one way. Now look at the denominators. I could do what we're going to learn to do later on, and that's going to be to cross multiply. That would work. But I believe that this is a little bit less work. That's what I believe for this problem. Jonathan, please make sure you find out where you need to sit. Separate good. Eileen, please make sure you find out where you need to sit. So when I look at these two denominators, there's one side, the right side. Here's the left side. What do I need to attach to the left-hand side so they're exactly the same? Anybody? What do I need to attach to the left? A 2. You can never add something. You can never go plus or minus. You can only attach by multiplying. Whatever I do to the bottom, I must do to the top to keep the value of the left-hand side the same. Is the left-hand side and the right-hand side now exactly the same in the denominator? Okay? When they're exactly the same in the denominator, I cross out the denominators, and I only have to solve this. Again, I'm going extremely fast right now. I have 2 times the quantity x plus 1 equals x minus 3. Remember that for me, please. You guys have a good memory. I have 2 times the quantity x plus 1 equals x minus 3. So I'm going to distribute first to get 2x plus 2 equals x minus 3. I'm going to do just very simple algebra here. Subtracting x, so I have 1x plus 2 equals negative 3. Then I'm going to subtract 2 to the opposite side. I'm going to come up to the top here. I have 1x equals negative 3, or negative 5. When I divide by 1, I still get negative 5. Here's what I need to go back to. I need to go back to the fact that I got x equals negative 5. Turn to your team right now. I'm going to erase this. I did the algebra. I got x equals negative 5. How do I know if that's a legit answer or if it's called an extraneous solution? So this is non-negotiable, even if you don't understand. Talking as a group. Can I count this answer, or do I have to say, nope, that won't work because it makes the denominator equal to 0? Talk within your teams. Ready, get set, and go. Does that work? There's 2 ways to do this. One way is this. One way is I'm going to plug it in -5 and -4 is -9. As long as it's not 0, I'm cool. I can plug it in here. 2 times -5 is -10. -10 and -8 is -18. Cool, it's not 0, it totally works. Another way to think of this is at the very beginning, we had x minus 4, and we had 2 times the quantity x minus 4. So think of this quantity right now. The only thing that would make it equal to 0 was 4. The only thing that would make this equal to 0 is x equals 4. I did not get 4, I got -5. Anything but 4 will work. Okay, we are moving on to example number 3. I'd like you to write this down. Thank you. Every problem we've done so far has a left side equals a right side. We haven't seen any other separation. The first 2 examples, I'll come back if you don't have this down. The first example had the denominators exactly the same. The second example was really close to having the denominator same. We just had to multiply by 2 on one side. So we have more than one way that we can attack this, but what is the simplest way is what we want to learn. Who remembers what x squared minus 9 factors into quickly? Anybody go? X plus 3 and x minus 3. So underneath that, we want to do the least amount of work. Please, underneath x squared minus 9, write x plus 3 and x minus 3. My goal is to get the denominators exactly the same. So they both have the quantity x plus 3, and I'm going to underline that right now if you're not seeing that. What do I need to attach to the right-hand side so now the denominators are exactly the same? I need to attach the quantity x minus 3. Now to keep the right-hand side the exact same value, whatever I attach to the bottom, I need to attach to the top. Now they both have the quantity x minus 3. Now I'm choosing to do this because really quickly I could factor x squared minus 9. I could do it in my head. It seemed pretty simple. Once the denominators are the same, they both have the quantity x plus 3 and x minus 3. I wipe them out. And now working as a team, I'm going to go on to the next slide just to write this pretty. It was 4x minus 9 equals x minus 1 and x minus 3. Okay, working as a team, this is going to determine how much work you have. I'm going to give you 1 minute to see how far you can get in solving this. And there's multiple ways to solve. You've learned how to solve using factoring when possible. The quadratic formula always works, completing the square. Okay, must be talking. Ready, get set, and go. If you and your partner and your tutor don't know what to do, I'll give the helpful hints up here. Andrea, would you grab 2 cups per team, put 1 green and 1 red out so I can let people know if I feel like they are working together to the level I want them to. Good help, Gabriel. Good help, Ray. Good help, Fabian. Nice job, If you need an extra helpful hint, you can look up at the board. I'm going to have you come up here. It's okay if you're not done. I foiled the right-hand side. And then on the left-hand side, I moved over a positive 4x by subtracting. I moved over a negative 9x by adding. I have everything lined up on the right-hand side. And now I'm going to combine like terms. So there's no other x squared. -3, -1, and -4 combine to give you -8. Okay, remember, sometimes you can factor, not always. When you can factor, it's generally the easiest method for students. You can always use the quadratic formula, and you can always use completing the square. I'm going to choose to try to factor here. What do things multiply to give us 12 and combine to give us a -8? That would be -6 and -2. When you do all the work, it ends up looking like this. What do we do at this point? We're going to set each one of these factors equal to 0, and we're going to solve. X minus 6 equals 0, x plus 2 equals 0. Add 6. Did I write something down wrong?
Yeah.
Thank you.
-2.
Thank you, Ulysses. So I have 6 and I have 2. So that's what I ended up getting. Well, what does it even mean? It means that if you took these values one at a time and you came back to this original problem here, I erased everything, this original problem, I believe 6 and 2. I believe those two are my answers. That means if I take 6 and I plug it in wherever I see an x, I do the math on the left and I do math on the right, they should be equal. But now, new in your math careers, we have to check for something called extraneous solutions. So there's two ways to do this, okay? I'm going to refactor this just so we can see what that looked like. Okay, what would you plug in for x here, and now this thing would equal 0? Anybody? What would you plug in? If you plug in this value for x on the right-hand side, the denominator equals 0. Negative 3. And if you don't see that, then do the math. X plus 3 equals 0. Subtract 3, x equals negative 3. Okay, neither one of my answers is negative 3. Cool, I'm good on the right-hand side. On the left-hand side, I could do the exact same thing. So I've already worked with the x plus 3. Let's work with the x minus 3. Add 3 to the opposite side, add 3 to the opposite side. Okay, neither one of my answers is positive 3. I'm good to go. That means both 6 and 2 work. Now, as Ray mentioned in the back on the last problem, if you're like, I really don't follow that step, an alternative way to check to see are these extraneous solutions or do they actually work? Extraneous solution means you do all of the math right, but when you plug it in, you break a math rule. We end up with 0 in the denominator. So here is a different method. The other method could be to plug it in. When you plug in 6, you get 9. As long as it's not 0, you're good. When you plug in 6, you get 36 minus 9. That's not 0. I'm good to go. Now plug in 2. 2 plus 3 is 5. It's not 0. Plug in 2. 2 squared is 4. 4 minus 5 is not 0. They both work. Can you talk as a team, please? Make sure everybody understands. How do you check to see if something is extraneous? No 0 specifically where? The denominator. Awesome. Every problem we've done so far we have seen some type of connection with the denominators. Either they're the same, or all I had to do is multiply by a number, or multiply by a quantity. We're not always going to get that lucky. So when we look at this particular problem, please take time to write down example number 4. We do not see correlation between the denominators. So what do we do then? We're going to go back to your middle school math after you write this down. In the middle school math, if I give you a problem like this, you are not going to write down what I'm putting down right now. You are not going to write this down. If I gave you this very simple equation, I said, please solve for x. And if it's a fraction, you can put it in decimal form or reduce it as a fraction. Okay, what would you do? You'd go, okay, 3 times 4 is 12. Don't write that down. 10 times x is 10x. You divide by 10, you divide by 10. And then 12 over 10, they're both even. I'm going to divide to get 6 over 5, and that's what you learn how to do in middle school. Same concept now. We see no correlation in the denominators. So I'm going to take x times this quantity and 5 times this quantity, and I'm going to set them equal. We're going to do that in the next part. I'm going to get you started, and you're going to work as a team. X times 4 minus x equals 5 times the quantity 2x plus 1. So what you are going to do right now is you're going to distribute the x, distribute the 5, move everything to one side, and then you're going to solve using one of 3 methods. Factoring if possible, quadratic formula always works, completing the square always works. You have 2 minutes. 2 minutes, please. I'm going to start. You can check with me if you need help. Tutors, please check with your group to make sure they're understanding what to do. I move 4x to the opposite side by subtracting. Opposite of positive 4x is negative 4x. Opposite of a negative x squared is a positive x squared. There's nothing left now on the left-hand side. And I'm going to line this up before I combine like terms. You are welcome to combine like terms in your head. Positive 10x and negative 4x is a positive 6x. Not everything is factorable. I am going to see is this factorable. What multiplies to give us positive 6 combines to give us, multiplies to give us positive 5, combines to give us positive 6. Did I write that down correctly? I did, didn't I? Yes? 1 and 5. 1 times 5 gives us a positive 5. 1 plus 5 gives us 6. X plus 1, x plus 5. Whether the zero's on the left or right, we're going to get the same answer. Set each one of these factors equal to 0 and solve. Can you do some of that in your mind? I am fine with that. So I'm moving 1 to the opposite side, x equals negative 1. Moving 5 to the opposite side by subtracting x equals negative 5. Okay, you ready? I want one person per group to determine how do I know if those answers. So I've shown you two different ways to check. How do you know if negative 1 and negative 5 work? Tutors, please listen as the students discuss this and correct them if they're wrong. Ready, get set, and go. You have 30 seconds. How do I know if it works? Go.
You basically percentage of the denominators equal to each other, and then you just factor and find your zeros.
So one way to do it is to check by plugging it in. You have to check both the left and the right. If I plug this in, 4 subtracted negative 1, that's 5. It's not 0. Awesome, but I have to also check the left side. 2 times negative 1 plus 1. Well, that would be negative 2 plus 1. It's negative 1, not 0. So in both cases, the denominators, when I substitute negative 1, they do not equal 0. I'm good to go with this part. Let's check negative 5 now. Let's see if I can erase this. Let's now check negative 5. X equals negative 5. Okay, when I plug it in negative 5, I have 4 subtract negative 5. 2 negatives make a positive. 9 is not 0. Plugging in negative 5, 2 times negative 5 plus 1 would be negative 10 plus 1, which is negative 9. Again, it is not 0. In both cases, they work, so I have two solutions, negative 1 and negative 5. Again, this example 4, is different than 1, 2, and 3.
Good morning, Trevor Brown. This is a reminder that all students who are interested in taking the ASVAB test can report to the community room at this time. Once again, the ASVAB test in the community room at this time. Thank you.
What was different about examples 1, 2, 3 versus 4 is 4 has nothing in common in the denominator. There's not a quick way to make them the same. We're just going to cross multiply and solve. Okay, let's look now at example number 5. Please write it down. What number can go underneath the 3 and it does not change the value of a 3? A 1. Yes, there's more than one way to do this, but I think we're going to go back to the way you learned in middle school. We're just going to cross multiply. So I'm going to give you a chance to distribute the 1 to everything on the well, here we go. We're going to go 1 times x plus 2. That doesn't change anything. And 3 times the quantity x minus 5. Make sure to use parentheses. You ready? You have 30 seconds right now. 30 seconds to solve. Another 30 seconds to check to see, is your solution credible? Or is it an extraneous solution? Go, go, go. Multiplying by 1 does not change anything. Multiplying by 3 provides us 3x minus 15. You can move the x's to the left or right. It's totally up to you. I'm going to move the x's over to the right-hand side so I don't have a negative. Then I'm going to move the 15 to the opposite side by adding it. And I end up with 2x equals 17. Divide by 2. If I told you 17 over 2, I'm okay with you leaving it like that. Or what is 17 over 2? It is 8.5. 8.5. You could give me a decimal form, or you can leave it in a rational reduced form. Either one is 5. Fine. All we have to do is make sure this doesn't work. So think of 8.5. Let's come back here. 8.5. If that is the correct answer, we do not have 0 in the denominator. If you have $8.50 and you subtract $5, are you down to 0? Nope, it works. It does not make the denominator equal to 0. We're going to switch it up now. Now we have something different. Please write down example number 6. We're going to slow this down. So we have two different ways we're gonna have to solve this. Two different ways. When the problems get harder, I would suggest the butterfly method. Okay, right now we have two different ways. We can do the LCM method or we can do butterfly method. I'm going to describe both to you right now. We're going to start by doing the butterfly method. So in this butterfly method, this is what we're going to do. We are going to create a butterfly. Okay, so we're going to take 3 times x and write down 3x. That's going to be this part of the butterfly. Then I'm going to take 2 times 1. That's going to be this part of the butterfly. Whatever your symbol is becomes this part of the body, so it's a plus sign. So we have 3x plus 2. And now the last thing we have to do is this bottom part here is going to be when we multiply the denominators to get 2x. So this looks like 3x plus 2 over 2x. We just combined the two fractions on the left-hand side. Okay, let's slow that down once again. Okay, you ready? Let's slow it down once again. What we're going to do is we're going to create a butterfly that looks like this. Okay, there's going to be one wing. There's going to be the other. Here's a top body and a bottom body. That doesn't look like a butterfly. I totally agree. Let's see if I can draw that a little bit prettier. Let's see if I can do that a little prettier. Does that look a little bit more like a butterfly? It doesn't, does it? Dang it! We'll just go with my steps. All right, you ready? Here's step number 1. Please circle this diagonal. 3 times x is 3x. Whatever this symbol is, please put it behind. Now we're going to do the other diagonal. 2 times 1 is 2. You've done both diagonals. On the bottom, you're going to multiply the denominators. 2 times x is 2x. And set it equal, in this case, to the right-hand side. What goes underneath the 2? You can put this number underneath any value and it doesn't change it. A 1. Okay, you ready? As a group, please cross multiply and solve. Go ahead, please cross multiply and solve. How do I know if 2 works? The only way to know if 2 works is I go back to the original problem. X equals 2, and the only thing you cannot have in the denominator is a value of 0. So when I look at the denominators, if there is no x, then I don't worry about plugging it in. There's no place to plug it in. So there's no place to plug in a value of 2 here. There's no place to plug in a value of 2. When I plug in 2, it doesn't equal 0. That means this is a credible answer. X equals 2 is the answer. Please write down the next problem. So in this problem, there is a common misconception. Students say, oh, it'd be really easy. Don't follow what I'm going to do. It'd be really easy to make the denominators the same by doing this. X plus and x plus. See, I did it to the front or to the top and to the bottom. You can never add or subtract to make the denominators the same. You can only multiply. That will not work. So we're going to go back to this butterfly method here. I'm going to start on the next slide. So we're going to go 8 times 2. 8 times 2 is 16. Whatever symbol is in between goes in back of it. And then I'm going to take 8 times the quantity, x plus 2. In the denominator, I push the 2 together. So I'm going to multiply 2 times the quantity, x plus 2. And you could put x plus 2 first and 2 second. I just did it like this so that'd be easy for me to distribute. Set this equal to 5. Okay. Put a 1 on the bottom of the 5. We could distribute and then go ahead and combine, but this is what we're going to do. We're going to take right now, and let's do this. Let's rewrite this so nobody's confused. This is going to be 8x, and this is going to be plus 16. So if I bring this up, I have 16 plus 8x plus 16. I'm going to rewrite this. Okay, 16 plus 8x plus 16. 2 groups of 16 gives me 32. So 8x plus 32, that's in the numerator. In the denominator, I have 2x plus 4. And now I'd like you to use cross multiplication to solve for x. Go ahead, please, cross multiplication. Take your time. It does not matter which diagonal you work with first. That is a 4. Five times 2 is 10. 5 times 4 is 20. Doesn't matter which side the x's go to, whether it's the left or the right, it's up to you. Ooh, running out of space here. We got 12 equals 2x. When I divide by 2, x equals 6. I believe the answer is x equals 6. I'm going to go back to this original problem, x equals 6. Again, we're only focused on the denominator, so I'm going to circle the denominators. Of the 3 denominators, we only care if a denominator has an x. Otherwise, I can't substitute in the value x equals 6. X equals positive 6. Okay? So this doesn't have a variable x to substitute into. Does not have a variable x to substitute it into. When I plug in 6, 6 plus 2 is 8. It's not 0. It works. Here's your next one. Okay, ready? As a team, I want you to butterfly this. So I'm going to start off really slow. If you're feeling confident, you're going to take off. So I'm going to go 3 times 1 is 3. Bring down the symbol plus. X times x is x squared. Not 2x, x squared. And then this bottom part, what do I put down here? I'm going to multiply the denominator. So x times 1 is 1x. Again, I put a 1 underneath the x. Whenever you don't see something on the bottom, it is a hidden 1. And we're going to set it equal to 4 over 1. Cross multiply and solve, please. There is nothing left on my right-hand side. These cancel out. There's nothing left. On the left-hand side, if I write this in standard form, I have x squared minus 4x plus 3. Not all trinomials are factorable. Let's see if we can factor this. What multiplies to equal positive 3 and combines to equal negative 4? That'd be negative 3 and negative 1. X minus 3, x minus 1 equals 0. I set each of the factors equal to 0 to solve. One answer is 3. The other answer is 1. And now I got to make sure they work. I believe the answers are 3 and 1, but how do I know if they work? I'm going to come back here. Again, I believe the answer is 3 and 1. If it has a 1 on the bottom and there's no x, I don't need to worry about it. There's no x to plug it into. I can plug in 3, it's not 0. I can plug in 1, it's not 0. Both of those answers work. Can I have a 1 through 5? We have 2 problems left on your understanding, not the speed of the understanding. Okay, let's go. Let's make it harder. Go. We'll go slowly over this one. If you can recognize when there's similarities in the denominator, it could save us some valuable time. And this is one of the examples. So before you take off on your own on this, let's do this one together. I'm going to go underneath the first denominator, and what can I factor out? NX, I'm left with x subtract 2. So I have two groups. I have an x, and I have an x subtract 2. Can everybody see how this is an x, and this is an x subtract 2? So I'm thinking to myself, if I find a common denominator, and I attach it to each one of the missing pieces, that this is going to be pretty easy. So I'm going to come back here, and I'm going to write this over. 10 over x and x minus 2 plus 4 over x equals 5 over x minus 2. There's more than one way to try to do this problem. So if you try to do the butterfly method, it absolutely works. I just think in this case, because I saw some similarities in the denominator, this second term, what is the denominator missing to be the same as the first denominator? Which piece is it missing? Okay, whatever we attach to the bottom, we must attach to the top. The very last fraction, what is the denominator missing to be exactly the same as the first denominator? Okay, whatever we attach to the bottom, we must attach to the top. Now, why did I choose to use this method in this particular problem? As soon as the denominators are the same in equations have an equal sign, not expressions, we get to wipe out the denominator and we only have to solve the numerator. So 10 plus 4 times the quantity x minus 2 equals 5x. Go ahead and solve for x, please. Okay, before we talk about this next part of this problem, can you make sure everybody in your group understands how to get x equals 2? Go. Check with your group, make sure they understand how to end up with x equals 2. I'm going to go back to this first problem, and now I want you to determine as a group. We got x equals 2, and I believe I did all the right algebraic work. Is x equals 2 a viable answer? Does that work? Talk with your group. Does that work? I'm hearing no's. Why? Why doesn't it work? As long as you find one denominator in the whole problem that when you plug it in, it ends up with 0. So I started on the back side. I plugged in 2. 2 minus 2 is 0. As long as you find one denominator in the entire equation where you have a 0 on the bottom, this no longer can be counted. So what do we do when there's no other answer? We write no real solution. Now, could you do this problem and use the butterfly method? Absolutely. But I think that I see something where there's a similarity. Talk in your groups right now. What do you see that there's a similarity that we could maybe make this easier? Talk in your groups, not so loud. What does x squared minus 16 break into? Okay, are you ready? Here we go. I will reduce for you. Your homework down to 1 hour tonight. If you could do me a favor and walk yourself through this together. You're talking through your work. So let's see what you can do in 1 minute, and I'm going to stop you. Go 1 minute. Talking together as a group.
I tried out. I'm watching. Don't do that. I'm watching. Alright, I won't watch you. Just tell me if you get stuck. Tell me what part.
My first goal was to find the least common denominator, and that will not always be the case. If I don't recognize a pattern within denominators, I'm not taking time to do that. I'm using the butterfly method. But this one is pretty simple. We have two quantities, x minus 4 and x plus 4. Once the denominators are all the same, make sure whatever you attach to the bottom of a fraction, you also attach to the top. I get to wipe it out. And I have 3 times the quantity x minus 4, subtract 2 times the quantity x plus 4 equals 3. And so I'm just going to distribute 3x minus 12 minus 2x minus 8 equals 3. Combining like terms to get 1x. Combining like terms, minus 20 equals 3. Add 20 to the opposite side. You correct me if I'm wrong. Do you get an answer of 23, yes or no? Can you raise your hand if you end up with 23? I must have made a mistake. I don't see any hands up. You got 23?
You got 23 too.
Okay.
I think it works right.
Okay, so let's figure out, as long as it works for every denominator, we're good. As soon as any denominator is 0, it doesn't work. So if I plug in 23, 23 plus 4, that's not 0, we're good to go. 23 minus 4, that's not 0. 23 squared is a hell of a big number. When you subtract 16, it's not 0, it's good to go. So 23 is the correct answer. Again, when would I use this method of finding the LCM? Only when I look real quickly and I notice a pattern in the denominator. If I don't, I'm not taking time to use that method. Okay, let's go on to our very last example. So this is an Algebra 1-2 standard. You may have forgotten how to do it, so we're just going to remind you. Think of this as 3 different groups. I'll wait till everybody writes this down before I circle the 3 groups. This is one group. This is the second group. And this is the third group away over here. So think of it as 3 different groups. And underneath the 2, please write a 1. And we are going to first focus on these numbers. So my goal here, is to get rid of a fraction. I don't like working with fractions. So 1, 3, and 4, look at those denominators. What is the smallest number that 1, 3, and 4 all nicely divide into? Anybody? 12. Okay, remember we have to keep the equation balanced. So I'm going to take 12 times each one of those groups. So times 12, and times 12. Please do that. My whole purpose is to eliminate the fractions. So what I just did is I took 12 times this quantity, and I took 12 times this quantity. So essentially 12 times each one of these. Okay, you ready? 12 times 1 is 12, but then when you take 12 and divide it by 3, you end up with 4. So I'm really going to take 4 times this quantity next. Okay? Coming back here again. 12 times 3 is 36. 36 divided by 4 is 9. We are only, give me 1 second. We are only taking it times this outside number. We are not taking 12 times the inside. Okay.
They got 7 because...
On the last problem?
Yeah, because you know how...
Let me come back and we'll find my mistake. They found a mistake. Okay, give me 1 second. And then 12 times 2 is 24. Okay, you ready? I want you to solve right now for x. Go ahead, please.
They don't know to distribute the negative at the end. So they were like this 2x plus 4 instead of minus 3.
Oh,
So
what's the problem?
the last one, that's why I got 7. I think it's important that you say that.
Okay, we'll come back to that.
Okay. Does that make sense?
Show me on that part in just a second. Same burden or no? Same person? Figures aren't done yet. Okay, why do I not in this problem have to check for an extraneous solution? I don't have to check. Anybody? There's no denominators there is denominators of 3 and 4 and 1, but they don't have a variable. Again, there's no x in the denominator, so I don't need to check if this is an extraneous solution. This is my answer. We're going to come back to this problem, and this last problem, this is where Ray wants everybody just to see consistently. See how this is a negative sign here? This negative sign, it's not just a 2 that has to be distributed, it's a negative 2. So whatever sign is in between them has to come down as well. So we have negative 2x and negative 8. So whatever sign is in between, when you bring it down, whether it's plus or minus, please be conscious of that. What I need you to do right now is take out your homework. Please take out your homework. Go to where it says various equations number 1, There are 14 questions. I want those 14 questions completed outside of class. You have answer keys that are behind it. Always check for extraneous solutions. You are going to send me a message on any problem where you're not getting the right answer, and I want to start class by going over the homework problems you're not getting. If you attempted them, then I want to go over that. We're going to check your homework. Your tutor is going to be checking your homework. Okay, that's what I want you to do, and you have a short video to watch. So I'm going to add that to our team page so everybody knows. You have right now, you still have 7 minutes remaining. I want you to start your homework and to see, can you get 2 or 3 problems done before the bell rings? Please go ahead.